Hello everybody, and welcome to exercise 3 on page 141 of the workbook. And we're going to work through just part A of this together. I'll leave part B and C for you to do and maybe look at the written solutions. Okay, so this is our first example of a problem where they would like us to calculate the first and the second partial derivatives of a function. Okay, so let's start with the first derivatives of f of xy equals x ln of y. Okay, so that's like asking us to take the derivative with respect to x of this function. And when we're taking this derivative, remember, we're treating x as the variable and y as a constant. So this ln of y that you see here, that only involves y, so that's like a big constant that we can pull outside of our derivative. So we could rewrite this as ln of y times the derivative of x, and the derivative of x is just 1, so we should get an answer of ln of y. That's our partial derivative with respect to x. Okay, moving on. What about the derivative with respect to y? Okay, well this time, y is our variable and x is being treated as a constant, so that x that I underlined, we can pull that outside. And we're taking x times the derivative of ln of y. What is the derivative of ln of y? Well, that's 1 over y. So we're going to get x times 1 over y, or if we like, we could simplify that into one fraction and just write it as x over y. Okay, there's our derivative with respect to y. Okay, so we've taken care of the first two derivatives on our list, and we're ready to move on to the second derivative, starting with fxx. Let's remind ourselves of what that means. It's basically like saying we're going to start with the derivative with respect to x, which is sitting right up here. And then we want to take the derivative of that one more time with respect to x. Okay, that would be taking the derivative with respect to x twice. So we need to take the derivative with respect to x of ln of y. What should we get there? Well, there are no x's in this expression. Y is being treated as a constant, and so we should just get 0 out of this derivative. Okay, so there's fxx. Moving on, what about fyy? Okay, well there, we're trying to take the derivative with respect to y twice. So we've already taken the derivative with respect to y once. That's this x over y. We just want to take the derivative of that one more time with respect to y and see what we get. All right, now we could use the quotient rule on that, but just to get around that, I'm going to rewrite this as a product. So x over y is xy to the negative 1. And since y is our variable, we can take the x that I'm underlying and pull that out. And all we really need to take the derivative of is the y to the negative 1. By the power rule, that's going to be minus y to the negative 2. And so we get an answer that looks like negative xy to the negative 2. Okay, or if you like, you could write that as negative x over y squared, however you want. Okay, finally, we've got one more derivative to take, the so-called mixed partial, fxy. Okay, and notice that the derivative that's being taken first is x. Okay, so we want to start with the derivative with respect to x, which we've already calculated to be ln of y. So that's our starting point. And then we want to take the derivative of that with respect to y. That's our second variable. So putting it all together, we're taking partial y of ln of y. And the only question is, what do we get there? Well, derivative of ln of y is 1 over y, and so that should be our answer.